Okay, for this question, most of you are able to solve. So I'm going to spend more time in part B, which many of you are still having issue doing it. So to sketch a ray diagram is actually quite simple. Just, well, there are only like 3 rules to it. So if you are still having trouble, do get a consultation slot with your physics teacher, and then we will help you. So first thing first, they are telling you that it is a 1 cm object that turns into a 3 cm image, and it forms on a screen. So I know that it has to be on the other side of the lens. They also tell you that the image is about 6 cm away from the object, not from the lens, from the object. So in this case, let's quickly do this. 1 cm tall object, okay, fine, 1 cm tall. Let's make this 1 cm. Then after that, 3 times magnification. Okay, 3 times magnification. Let's use blue. 3 times magnification means is around this size. Okay, and it is 6 cm away from the object. Okay, so 1 cm, 2 cm, 3 cm, 4 cm, 5 cm, 6 cm, 6 cm is here. Yeah, 6 cm is here. So let me just put it. Okay, so I have gotten this criteria, and this criteria. Now we just need to form the rays, which is quite straightforward. First rule, the image has to come from the object, right? So image come from the object. Yeah, and the only way that I can have a ray that doesn't refract as it passes through the lens is that this red line must cut the optical center. So I already know the optical center must be here. This will be my optical center, and optical center basically is where your lens is. So in this case, I have also figured out where my lens is. So my lens is around here. Okay. Then the second rule of doing your ray diagram is, of course, get this horizontal line. Maybe I use red, maybe green, to show that it is another line. Right, then I know that when these rays strike the lens, there will be refraction. And by the design of the lens, the refraction will actually bend the way towards the converging point. And the place whereby this ray cuts the principal axis, this will be my focal point. So once I have all this, I just need to add in the convention of the thing, and basically I can answer these 2 questions here. Yep. So for part B, I'm checking whether you understand how the ray diagram is trying to symbolize. What does the ray diagram symbolize? So the first thing that you need to know about this ray diagram is, the first question that you need to ask yourself is, why do you draw these 2 rays? Does it mean that only 2 rays of light get emitted out of the object? No, right? The object actually will emit all sorts of light in all directions, like what you have learned in your lower set. So it will keep emitting light in all directions, just like what an illuminated object is. And the problem is, if we are interested in these rays, the problem is after it hits the lens, right, we have no clue how it will get refracted by what angle. But based on the rules of ray diagram, we know that if it is a horizontal light, it will definitely cut the focal point. So because of that, we will, whenever we are drawing the ray diagram, we will always draw this horizontal line, and then we will bend it towards our focal point, or we bend it to the converging point. By the same reason, whenever we draw ray diagram, we will also draw a ray from the object to the optical center, because we know that when light travels through the optical center, it won't refract. So these two special beam of light enable us to find where the converging point is. That's all. That is why we are making use of these two rays to construct our ray diagram. It doesn't mean that the object only emits two rays. And once we have found the converging point, we can then tell ourselves that, oh, okay, for all the other rays, it is going to get converged. Oops, sorry, used the wrong pen. For all the other rays, it is going to converge at the convergent point. So by drawing that two ray, we basically we save ourselves some time, because once we have located the convergent point, all the other rays that is being emitted from the object, and those rays, after it cuts the lens, will basically get refracted at such an angle that it will converge to the convergent point. The second question that we usually get is, does it mean that for this particular object, only the tip is emitting light and the rest of the body does not emit light? The answer is no, the whole body is emitting light. It's just that we don't draw this ray. If not, our ray diagram will become very, very messy. And the second reason is that it is not necessary to draw them, because as long as we are able to locate the tip of the object emit light, and it forms an image of the tip on this side, we can then construct the rest of the image from this point to the base. So we need not draw ray diagram emitting out from the body of the object, because we don't need to. We can reconstruct it, right? So because of that, we don't draw those lights. But does it mean that it doesn't exist? No, right? Ray diagram is just a tool. And with this understanding on how this ray diagram help us, we can then answer the questions in part B with greater confidence. So let's take a look. The lens is shifted further away from the object. So if we shift the lens alone away from the object, what happens is that the convergent point will move as well. But in this question, has the screen moved? No, right? So if, let's say, the lens move, will the convergent point be on the screen anymore? It won't, right? And what will happen if the convergent point is not on the screen? Let me give you an illustration. Let's say I want a screen. Let's say I put the screen here instead. What will happen is that the image of the tip over here will end up creating multiple image of itself on the screen if the screen is placed here. Each of these rays will form an image of the tip. And when that happens, basically the tip will overlap and you will end up with a picture that is very, very blurred. For example, I see if I can find an image. Okay, in our daily life, it is called out of focus. And it looks like this. It looks like this. Out of focus. Meaning that a sharp dot will appear as a blur of a group of dots. And this is exactly what happens here, right? One emitting object end up with 6 overlapping dots. And it will appear quite blurred. So because of that, if you shift the lens, the convergent point will no longer be on the will no longer be on the screen. And because of that, your object here, your image here will become blurred or out of focus. Right? Okay, second question. Let's remove some of these things. Wait a minute. Okay, let's go back to what we have. Second question, top half of the lens. Wait. I forgot. Image will become out of focus or blur. Okay, second question. Top half of the lens covered. So if now I block the top half of the lens, okay, so now I block the top half of the lens. This part no longer there. Right? What will happen? Well, then this ray can no longer appear. Am I right? But how about the bottom half? Well, the bottom half of the ray will still be able to converge at exactly the original place where it is on the screen. So because of that, you are still going to get a sharp image, but with lesser ray. Initially, you have 6 rays converging it there. Now, with the top half of the lens covered, you have only the bottom lens working and focusing 50% of the ray, refracting 50% of the ray to the converging point. So, you are still going to get a sharp image, right? But now with lesser ray converging there, the image will be dimmer. Yeah. Lastly, to check whether you really understand, right? Half of the object is covered. So let's revert. Right, half of the lens is covered. Half of the object is covered. Oh, okay, I deleted those. So your image will be dimmer. Right, still sharp. Half of the object is covered. Now the object is where the light get emitted. So if you cover half of the object, it means what? Only half the image will show. Correct or not? So because of that, you will only have half of the image. Because your object is the source. And if your source is covered, then obviously you lost half the information. So your image will be half, right? You just, right? You deleted 50% of the source, then obviously you won't have 50% of the outcome, right? So I hope with this question, you get a better understanding of ray diagram and how it works, and you won't make the same mistake in your prelim.